Yeah, hi. The last important concept of binomial theorem which we have to consider. For example, we have a plus b power n, where we don't have n. How to expand when we do not have known power? The following things have to be considered. Number one concept is factorial, and the other is NCR. What factorial is actually, you have seen, you will see a sign like this on your calculators, 5 factorial. It means it will be expanded as 5 into 4 into 3 into 2 into 1, and then you will write an answer as 120. 6 factorial, 6 into 5 into 4 into 3 into 2 into 1. Alright, and then you will be expanding as 1 factorial, 2 factorial, or 3 factorial, or 4 factorial, in a way that 1 multiplied by 1, 2 multiplied by 1, 3 multiplied by 2 multiplied by 1, 4 multiplied by 3 multiplied by 2 multiplied by 1 is equal. So it means that the factorial operation is going in such a way, like n factorial. It means n, n minus 1, n minus 2, n minus 3, n minus 4, and it will go on. So if we are not stopping, it is going on. We will not close it, but we will write a factorial sign which will be telling us that the multiplication of the bracket is continuing, the expansion of this factorial is continuing when we apply the factorial sign where we finish. So if we want to finish at this level, n into n minus 1 factorial, it means that it can open further as n minus 2, n minus 3, and n minus 4, and onwards. It means if you want to be limited to n minus 2, it's all right, because wherever we are required to expand till. So this is what we have factorial. And now the second thing is NCR. The formula for NCR is n factorial over r factorial bracket n minus r factorial. It means that when we are showing calculating 5c2, so we are going to have 5 factorial over r factorial is 2 factorial, and then 5 minus 2 factorial. So this will give us 5 factorial divided by 2 factorial into 3 factorial. How we can just further calculate is 5 multiplied by 4 multiplied by 3 factorial. I do not want to continue all the numbers here in this expansion. 2 factorial into 3 factorial. I can just cancel these two numbers, and then 5 into 4 into 2, and 10 will be our answer. So you can just directly go this answer from the calculator with the help of calculator. Now another example of this NCR is, for example, we have 12c5. Now it will be 12 factorial over 5 factorial, okay, and now 12 minus 5 factorial, n minus the factorial is outside of the bracket, not inside the bracket. So it will be opened as 12 factorial divided by 5 factorial into 7 factorial. So we can expand 12 factorial, 12, 11, 10, the decreasing numbers, 9, 8, and 7 factorial. And as you know very well that I want to just cancel this, so it means I have to stop at this very moment, and then I can just continue 12 into 11 into 10 into 9 into 8 over 5 into 4 into 3 into 2 into 1. So hence this important concept of the last important concept comprising of these two things, the one is factorial and the other is NCR. Now let's go to apply the things on particular question of past paper. Question number 3 part B is telling that in the binomial expansion of 1 plus kx power n, it means that it is telling us that to expand this bracket, after you expand this bracket, then go on to read the next part after comma. But before comma, the part before comma, you have to binomially expand this thing. So let's do it before we to go for the other rest of the question, because it will just not help us, but it will mix up the question. So let's do 1 plus kx power n. So the expansion tells us that nc0, whenever we have 1, we do not include this 1 in our expansion, because we are not writing. So in the expansion I'm using the black one, a blue one. So kx, that's kx power 0. Now nc0, nc1, nc2, nc3, nc4, and now you will ask me how long we have to go, because whenever we have a thing like 5, so we have to go till 5c5, but here we do not have any number in place of n, so we have to stop somewhere here. We can stop here. Now kx, 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 and kx. Let's see what's happening. 0, 1, square, cube, and 4. And now we are to see that this is completely going to become 1. Alright, now nc1, how we can open nc1? This is very crucial. nc1, as you know very well that we just saw how we can just open this ncr. Okay, one more thing which I want to add here, that is nc3. For example, I do not know n. Here I knew 12 and then I expanded it. So nc3 can be opened as n factorial over 3 factorial and n minus 3 factorial. Okay, so n factorial means we have to, n factorial means this is the meaning of n factorial, this is the meaning of n factorial, this is the meaning of n factorial. So it means that I can expand n factorial as long as I get it. Okay, now n into n minus 1, n minus 2, and n minus 3 factorial, because I don't want to expand more, and I want the number which is in the denominator. Okay, in the numerator I want to expand that much so I can get the number that is present already in the denominator. So the denominator number is n minus 3 factorial. So I can do what? You can just simply get rid of this factorial thing, and finally you are getting this family of the number. 3 factorial is 3 into 2 into 1. So this is your answer of nc3. So before you go further to your past paper question or the example question there earlier I opened, so you can practice nc2, nc4, nc5, and nc6. I am doing nc7 for you. So okay, I can do n factorial over 7 factorial and n minus 7 factorial. I can open it because this number is greater and this number is smaller. So I can expand the greater number as n into n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, and n minus 7. and have to write factorial. 7 into 6 into 5, 4, 3, 2, 1, and then minus 7 factorial. This is cancelled with this number, and then finally you get the remaining part of the thing. So NC7 is having the answer. So let's do our this thing. We did this to be 1, NC1. We require to expand NC1. How can we expand NC1? We can just do n factorial over 1 factorial and n minus 1 factorial, okay, and k power 1 and power x power 1. Now this NC2 can be expanded as n factorial over 2 factorial and n minus 2 factorial, k square and x square. And this thing, how can we open it? This thing can be expanded as n factorial, 3 factorial and n minus 3 factorial, k cube and x cube. How can we open this thing? NC fact 4, n factorial over 4 factorial and n minus 4 factorial, and further we can have k power 4 and x power 4, and it's going on. So now simplifying the factorials, in this is the coming step, we are going to solve the factorial thing, n into n minus 1 factorial, because in the denominator I require n minus 1 factorial. So in the numerator I have to expand that much, so I can get n minus 1 factorial. Okay, in the kx. Now n factorial, the second one, n into n minus 1, n minus 2 factorial over 2 into 2 factorial. This 2 factorial is this 2 in, and n minus 2 factorial will be as it is, n minus 2 factorial plus this thing I am going to expand this thing. How can I interpret it? So it's going to be, what is there in the denominator, n minus 3 factorial. So in the numerator I have to expand till n minus 3, n minus 1, n minus 2, and n minus 3 factorial. 3 factorial is 6 and n minus 3 factorial, and the variables. Now next, n factorial and 4 factorial. This, how can we write it? We can write it as n factorial over, no sorry, n minus 1, n minus 2, n minus 3 and n minus 4 factorial. And then 4 factorial is 4 into 3 into 2 into 1, 24 it's making, and n minus 4 factorial. So you are done with the expansion of the factorial, and you can see in the next step you can just cancel out this thing after you write 1 plus, and now you are left with n kx divided by 1 plus this thing. Acha, one thing which I want to see, that I haven't written this thing here, k square and x square, and also this thing here, k4 and x4. So nkx, the second term, the third term is, this is the first term, this is the second term, and this is the third term, fourth term and fifth term. We are at third term, so n into n minus 1 over 2 and k square and x square. Now you can see I have cancelled it. In the fourth term I'm remaining with n into n minus 1, n minus 2 divided by 6 dot k cube and x cube plus we can have a fourth term, so n minus 4 factorial is cancelled with this, so we are remaining with n into n minus 1, n minus 2 and n minus 3. Okay, 24, and then the family of coefficient k4 and x4. Now we read the question after the comma part, where n is greater than or equals to 3 and k is a constant. The coefficients of, for example, if we ignore this thing where n greater than or equals to 3 and k is a constant, of course they have meanings, but for the sake of solution we just leave them and skip them out from our reading. Let's go to solution of this part. The coefficients of x square and x cube are equal. Where are the coefficients of x square and x cube? The coefficient of x square is this all, and the coefficient of x cube is this all. So if they are equal, express k in terms of n. So we do this and apply this condition, and coefficient of x square is equals to coefficient of n into n minus 1 over 2 k square and n into n minus 1 n minus 2 upon 6 k cube. Okay, so coefficients you have to write, not the family of x square along with them. Okay, we are going to write x square and x cube here. That will be wrong. Okay, now you can cancel one something. N is cancelled with this n minus 1 is cancelled with this n minus 1, and k square is cancelled with this square. So you are left with 1 upon 2 here, and n minus 2 over 6 dot k. So you had to express k value, so it's going to be 3 over n minus 2 is equals to k. So your final answer is 3 upon n minus 2, and with this you have got 4 marks. Okay, I hope you have got this.